Hello everyone and please welcome to Expert C++ Programming, and today we are going to learn about bitwise operators and not going to discuss all the operators today. We are just going to discuss about only first operator, and in the previous videos you can see all the operators one by one, okay? Because if the video becomes too long then it will become a little bit boring. And just another thing I want to tell you that these operators are a little bit harder to understand because not everyone is learned about this. So if you ask your faculties or your teachers, or probably they don't know about these, okay? If they are genius then they know about this. If they are programmer doing real-time programming then they must know this. But some are just faculties just to take some classes, and probably they don't know, okay? So I respect all of them, I don't mean anything about them. So first of all, let's start our video from here. So today we are going to discuss about only AND operator. You can see this is different from logical AND, okay? This is different. These all are bitwise operators and generally not used, but asked in interview questions so frequently because not everyone knows this, okay? First of all, let's discuss about why these are used. Suppose you are making a circuit, because this C++ language is used in operating systems. Suppose you are making a washing machine, or you are making a clock, a digital clock. You are making a device that counts your heartbeats or counts your steps, how many steps you walk today. So this is useful. Suppose you are making a device that diffuse any bombs. Bombs means real-time bombs, okay? Not talking about games. So these are all about circuits. Generally we talk about our computer. There are CPU. Actually not all the big box is called CPU. CPU is just a little bit circuit. So this depends on a little bit electrical subject, but interesting, very interesting. So first of all, we all know about AND gate. What AND gate does: takes two inputs or whatever number of input takes. If all the inputs are high or all the inputs are 1, then output will be 1. But this checks one by one. First two are 1, then 1, or you can say that if any of them is 0 or low, then output is low. So but what happens actually in the circuit, it checks one by one, not all can be checked at once, okay? So suppose, okay, we are going to take integers, and why we take integers we all know, because that is a little bit easier. And if you want to take characters, then that will be more easier for this concept only. But we are going to take integers. You can do with floats by yourself, because this is very easy once you understand, okay? Suppose, okay, first of all, let's just take integer a, and we are going to assign some values to a. A is equals to size of, okay, size of integer. So what is the size of integer variable? We are going to know this first of all, because this is very important. Okay, there is nothing in the output. What happens here? Okay, we have not printed value of a. Okay, printf %d for integers, and the integer is a. Okay, so what is the value of a? So value of a is 4. But generally what happens? Value of integer is 2. Okay, no problem, it doesn't matter whatever the size is, but sometimes it matters. So first of all, we are going to, okay, just consider small numbers, because for big numbers it is very difficult for us, but computers do everything faster. It is genius in calculations for big numbers, and that's why. So let us assume that, okay, we are going to take two variables. B is equals to, okay, let us take 3, and a is equals to 3. So if I put, okay, so what should I do? And so where it is used, Okay, suppose integer c is equals to a and b. So what will be the value of c? So printf we are taking a percentage d for integers, and we are taking c here. Okay, we are going to compile it and run it. What happens? Okay, answer is 3 because a and b all are 3. That is not true. Okay, for now just take b is equals to 2. Save this and compile this and run. What happens here? It is 2. So can you see that it gives you smaller numbers, but that is not true. Okay, just take it as 3. So okay, we need some space here. I'm going to put some comments. We need some space. Okay, so a is equals to 3, and if you put 3 in binary numbers, then you can put it like 1 1. This is 3. And if you put b is also 3, that is also 1 1 in binary numbers. And c, okay, c is not known by us. So first of all, this one here, so answer of AND gate is 1, and then this one here and this one here, so answer of 1 is 1. So c is 1 1 in binary, so 3 in decimal. So if we take b is 2, suppose we have 2 here, then b will be 1 0 instead of 1 1 because binary of 2 is 1 0. So what happens for c? Okay, so 1 1 AND gate is 1 and 1 0 AND gate is 0. That's why c is equals to 1 0 and answer is 2 because 1 0's decimal is 2. Okay, suppose we take here 5 and take b is equals to 4. So what happens? This is 3, so 5 is 1. Okay, 1 here and 0 here. 5 is 1 0 1 and b is 1 0 0. Okay, so my mistake here. A is 5 and b is 4. Okay, so 5 is 1 0 1 in binary and 4 is 1 0 0 in decimals. So 1 and 1 is 1 because AND gate 1 and 1, so 1. 0 and 0 is 0. 1 and 0 is 0. So answer is 1 0 0. This is 4. So this will print 4 on the screen. Okay, let's check here. Okay, so you can see 4 is answer. So this is how Bitwise AND works. Same Bitwise OR. This all works same. But you can see next tutorials for this OR operators. I hope you understand this and you don't have any doubts. If you have, let me know, comment below. Thank you very much for watching. We'll meet you again in the next video.